I'm Vignesh from Team 24, and our topic is Smart Tour of Museum. Our team members are Akila Paturi, Bindya Vundavalli, Harshavardhan Yalavula, Haripriya Gautam, and myself, Vignesh Ramesh. Our problem statement is to provide a virtual smart tour of museum, which is specifically focused on museum data. This project aims to develop an application that provides relevant information on museum artifacts and artists of the Smithsonian or American Art Museum based on semantic querying. The application takes keyword as input from the user, and based on the search type, artist, artwork, or artist and artwork, which makes use of NLP, the results are retrieved and displayed, thereby providing a search engine to the user to get more information related to the artifacts. The high-level design of our project involves a web application with a search engine, and we have a web server which queries the FuseKey server, which has the ontologies hosted in it. This is the high-level design of our project. Our front end is built using Angular, and our backend service is built using Spring Boot. We also have a Flask Python script to perform the NLP operation and extract the keywords from the input string. There are mainly two ontologies used in our application. The one is artist ontology, the second is artwork ontology. The artist ontology contains information related to the artist and is used when the user selects the search type as artist. The properties defined are has artist ID, has artist name, has image URL, and has biography, which are some related data related to the artist. And the artwork ontology contains classification, dimension, and position classes that describe about the artwork. It has properties has title, has artwork ID, has classification, etc., which are related to the artwork in particular. The solve file is queried when user selects search type as artwork. This is the overall ontology diagram of the artist ontology, which is linked to the artwork ontology. We'll be able to see the various data like has death date, has birth date, has produced, has biography, uh, the related artwork, the nationality, etc., which are related to the artist in particular. The artwork ontology is a bit more extensive than the artist ontology, which has extra uh, uh, entities, which include the position of an artwork, the classification, the dimension, and several other properties which are related to the artwork. This is the GitHub link to our project's repositories. Now I'll brief about the roles and responsibilities. Akila worked on data collection, front-end development, and documentation. Bindya worked on ontology design, front-end, APIs, and integration. Haripriya worked on ontology design, selfie plugin, loading the instances in the FuseKey server and setting up AWS, transformation rules, SparkQL queries, and backend. Harshavardhan worked on data cleanup, front-end, creating virtual instances on AWS cloud, and installing FuseKey server on cloud instances. And Vignesh worked on data cleanup, backend, and NLP model for the third type of query, which includes both artist and artwork. Now I'll brief for the code snippets. The backend is developed using Spring Boot, which is based out of Java. Here we are following a model view architecture where we have several controllers based on the input search given in the UI. If the input search given in the UI belongs to an artist, then this particular path is invoked and this particular uh, code flow is taken. Similarly for artwork and the third type of general query where the input could be an artist or an artwork. The input to all these controllers involves a string name, which is basically the input string from the UI. And for the third controller, the input is a keywords model, which has basically a list of keywords which are generated from the NLP model. So when we have the input string, we are trying to generate a SparkQL query, which searches the artist ontology based on the artist name given from the UI. So this is the query which is being run in the artist ontology. For the artwork, a similar query is used where we query the artwork ontology. So once the SparkQL query is generated based on the input string, we are fetching the records by querying the SparkQL and returning an array of this artist objects. Similarly, for the design is similar for the artwork also. In for getting the results from the Fusky server to our backend Spring Boot application, we are using a module called Apache Jena, which is responsible for framing the query and getting the response and everything behind that. For the general query, we are getting a list of keywords which are generated from an NLP model, and we have several models which we have created so that we can map the result set. I'll go through the Python code which generates the keywords from the input string. So this is a simple Python script. It's a Flask server basically, and inside this we have this particular slash extract path, which basically returns the list of keywords which are generated by an NLP module called Yake. And here is the part where we uh, pull the model and extract the keywords from the input string. So the Flask script. And now I'll just go through the UI to show how everything works. So this is the home page where we just see an image of the museum, and there are two input fields here. So this is the second field contains three options. So first is for artist, the second is for artwork, and the third is for the searching, a general search kind of thing where we search based on artist as well as artwork. And the first is our regular text box where we'll be able to search anything. For example, if the input string is George, I can just search based on this George input string and select that this is an artist. So if I hit the submit, I should be able to get the details of all the artists who have this George in their first name or last name. Images are optional for some of the data. If images are missing, then no image is displayed. Otherwise, we'll be able to see the data. So that's it about the artwork flow. And in the second case, I'll just select artist and I'll just give, sorry, artwork. And then I just give buffalo as an input string. And if we see, we have this buffalo in the title of this artwork, and it has some description about the artwork as well. So this is about the second. And the third flow is a combination of both artist and artwork. So for example, let me give tattoo and buffalo and give the artist and artwork here. So what it does is the UI makes a REST API call to the Python script, which is a Flask server, and the Flask server returns a list of extracted keywords from the input string which we are giving here, and the extracted keywords are then sent as a list to the backend Java service, which then fetches the related data using SparkQL from the Fusky server, and then returns the data to the UI, and UI displays the data. The input is based on two keywords. One is tattoo and one is buffalo. So from the input sentence, the NLP model should return the two keywords tattoo and buffalo, and the search happens based on those two keywords separately, and the results are displayed over here. So in this particular result, we'll be able to see buffalo, and this is based on tattoo. So that's the third case over here. So that's the overall flow of our application. Thank you for watching.